long time no see. So finally we get together to have a nice workshop. Thanks for the organizers and thanks especially Professor Gani and Professor Chen for organizing this wonderful workshop. And this is quite rainy and it's a little bit cold, so we have here, we get together here, and I think all of us will take time to enjoy the beautiful sceneries. And we are just a load across the West Lake, so we have time and we have the opportunities to visit West Lake. So I'd like to give you a very brief introduction of the Zhejiang University and the College of Computer Science and Engineering. Hangzhou is the capital of East China, Zhejiang province, and it's very close to Shanghai. And we are called the Garden of Shanghai. In fact, we have 3 World Cultural Heritage Sites, which are the West Lake. I think this is the most beautiful in-city lake in the world. I think the second one is the Grand Canal, which connects Hangzhou and Beijing. And the archaeology ruins of Liangzhou city. The Liangzhou city has a long history of existence of human beings of 7,000 years. And Hangzhou is also full of innovation data. It is home to the headquarters of Alibaba, NetEase, Geely, and lots of high technology enterprises. And it also hosted the G20 summit and the Asian Games. Talking about the Zhejiang University, it was established in 1897. At that time, it was Qing Dynasty, and the name of it is Truth Academy. The truth in Chinese means seeking truth. In 1952, we have a very big reconstruction. The Department of Mathematics, Physics, Chemistry, Biology, Agriculture were moved by the government out to enhance other universities like Fudan. In 1998, 4 universities merged together to form the new ZJU. So we have 126 anniversaries last year. ZJU at the grounds, we have more than 70,000 people inside 7 campuses. 5 of them in Hangzhou and 2 others, one in Haining and one in Zhoushan, both in this province. And this is the statistics of the students and the faculty members. As for the ranking, I think the ranking is very important for everyone. For our, we are the 36th. For QS, we are the 42nd. And for the domestic ranking, we have the double first-class initiative. Double means the university and the discipline. So we are selected for both rounds. Both rounds in 2017 and 2022. A little more numbers. We have many patents. We have many highly cited Chinese researchers, and we are number 15 in the Nature Index. And we have 10 world top 1,000 disciplines according to ESI. The research funding is about 7 billion in RMB last year. Oh, not that last year, the year before the last. Last year it was 8 billion. We have many partners around the world. We have more than 200 partner universities, more than 600 global study programs, and 70 cooperative programs. And we have more than 4,000 international students inside the campus. Let's talk something about this college. Our college was established in 1956. At that time, it was part of the Department of Chemical Engineering. So after 60 years, we have been focusing on research, education, and innovation. I think the key issue, the unique characteristic is the connection between the theory and the practice. So we have the gene to form the innovation value chain of basic scientific research, technology innovation, application, and transfer, and finally commercialization. This is the timeline of our college. In 1956, it is we call it the discipline in the Department of Chemical Engineering. The name was Operation and Measurement Instruments in Chemical Production. So you can see at that time there was no automation, there was no intelligence, no such kind of things, because the computer is very expensive. It's very rare, was very rare, and only big companies can afford that at that time. So after several years, automation was a very sexy name, just like intelligence by now. So we changed our name to Automation and Instruments in Chemical Production Processes. This was the first time graduate students with a bachelor degree. In 1980s, we have the discipline changed to industrial automation, which we focus on the big industries, big process industries, and how to make the automation systems, both hardware and the software, to support those industries. Then we have many research centers like the State Laboratory of Industrial Control Technology and others. In 1997, we were the spin-off from the Department of Chemical Engineering. So we have a standalone department. Then in 2015, we built a college. Control is not a standalone field in the ranking system. So mostly it was part of the engineering. So for engineering, the US news ranking, ZJU was number 10. For times ranking, it was ZJU was the 30th, and for QS it was 29. In this college, right now we have 5 institutes. And the main research areas, we can list it as the follows. Industry intelligence and optimization control. We focus on industry big data, knowledge, automation, large-scale optimization, distributed control, intelligent manufacturing, smart manufacturing, etc. And we have robotics and intelligent management system. We focus on perception, planning, control, coordination, learning, and decision making. We focus on cyber security and safety for industrial control systems. We lots of topics inside this field. And we have smart sensing and measurement. Also, we have perception, and we have early warning, highly adapted optical detection, etc. So right now we have more than 100 faculty members and 1,300 students. We have more graduate students than undergraduate students. The undergraduate program is automation and robotics engineering. And for the master degree and the PhD degree program, we have computer science and engineering, and the other one is called the electronic information, which is the collection of all the information technology, and it's a big issue. And for the right, you can see the keyword cloud of our the keyword cloud of more than 4,000 journal paper titles collected for in the history. And so you can see what interests us are the control, of course, and also dynamics, optimal design and operation, model-based everything, and adaptive and distributed application. I think application is very, very important, right? So we have several national centers of the key state laboratory focusing on the fundamental research. We have the National Engineering Center focusing on the knowledge transfer and the commercialization. I think in this college, the knowledge transfer is very, very important. It is a key to bridge the gap between the academia and the industry. So I'm happy to have many industrial partners here to discuss how to bridge the gap. For PSE, we know we are always the tool maker. Tool maker for the complex system. But the point is how to make it work, how to make the real system work. So I think we have many to talk about. And also we have the National Engineering Laboratory for Security Technology of Industrial Control System. The final one is the National Center for International Cooperative Research for Quality Targeted Process Optimization and Control. We call it CIPA. I will talk about it later. Also, we have several creative research groups. Spin-off companies. It's very important to do the commercialization with our teachers and our alumni. And we have several very successful spin-off companies, like the Zhijiang. Zhijiang is one of the largest control system company now in China. And we have Yuwing Tech. And we have Cosine Solar. And we have iPlus Board. So this kind of spin-off companies, they contributed a lot to the industrial organization of China. In China, we have the most important awards is the national awards in science and technology. For the last 60 years, we have won 11 national awards. This is the list. And we have very excellent students. Today we have many students here, and I think the students are our future, right? I just want to list a number of cutting-edge research and innovation here in this college. Mostly in robotics here is the adaptive locomotion, the swarms of flying robots in unknown environment, especially in the bamboo forest. And we have artificial intelligence velocimetry, and we have drug target detection interaction, prediction, and also the particle checking. We developed several AI-powered robots. This field covers from industry and to the healthcare. These are several representative robots, humanoid robots, and quadruped robots, mobile manipulators, and bronchoscope robots. And also we contribute a lot to the field of mobile sensing and networking systems. In the field of microsystems and microengineering. So let's move to the process industry, because here we have the workshop of PSE. Everyone in China right now talks about the new quality productive forces. Chinese people know about that. I think quality is very important and efficiency is very important. There are many driving forces to enhance the process industry. The motivation is very clear. We are trying to develop the advanced integration of information. I'm sorry, informatization and industrialization. This will lead to intelligent manufacturing. We need to meet the demand of the society, and we need to do more technology development. Two sides, the quality promotion and the supply side reform is very important, are very important. Also, we need to establish automation in the instruments control, the discipline of chemical engineering, material engineering, mechanics, and also computer science and mathematics. So to meet the demand of process manufacturing, we have high quality, efficient, flexible, this kind of demand. And also we have the measures, the product quality, the flexible production, and the variable operation conditions to be very adaptive to the energy consumption and the emission reduction needs. So it is very important to have the multidisciplinary integration of the control, chemical, material science. As of polymers, the domestic capacity of polymer is over 1 billion tons. And the global annual growth is bigger than 5%. So the industry, they call for high quality, high value products, and less consumption and less emission. So is it possible to produce differentiated high-end products without or with very minor equipment modification? Is it possible to improve productivity and efficiency, and also reduce the consumption? So here, we can define the quality. Not only the quality of product, but also the loop quality, the control performance, the fluctuation, the equipment, the life cycle. And also we can talk about the operation quality, like the consumption, the economic target. And finally, we can talk about the service quality, like how to deal with the orders, inventory, and also logistics. So I think this is the extended definition of quality. But how to do in the AI era? Everyone talks about the big data, the large model, and lots of fascinating happenings. For artificial intelligence, we mostly talk about the computing power, the data, and the algorithm. And for the big industry, we talk about the mechanism, the first principle model, the process, the equipment, how to bridge the gap. I think after so many years, we are still focusing on the industrial intelligence, like the modeling, the control, and the optimization. This kind of understanding is based on the understanding of the control society. I think from the chemical engineering point of view, maybe you have a different view. To me, I think it's important to have a definition of the hierarchy of the intelligence. We can have this scope, especially the benefit defined to have a very clear upgrade of the intelligence. For loop 1, level 1 loop, we have the feedforward, the very basic feedback and feedforward design to deal with the nonlinearity, to deal with the sensor control actuator, the basic loop. For level 2, it is equipment or unit. We need to have the variables decoupled, we have to handle the constraints. For level 3, the process, we have to deal with the set point optimization, we have to deal with the condition change, we have to deal with the load change, the load distribution. For the level 4 and level 5, we deal with the plant and the supply chain, like the load distribution, the fault handling, the order, inventory, transport, capital, etc. So at different levels, we have different kinds of automation and intelligence needed. So I think this is it's time to integrate the process, equipment, optimization, and control together to have a picture. This is our view. The vertical is a tools. It's a tools. Like the theory, the method of control engineering. We are very familiar with this system identification, advanced control, real-time RTO, even process re-engineering, diagnosis. For the horizontal, we have disciplines like the chemical engineering, the materials engineering. So we can list lots of topics like how to predict the microstructure quality and how to make the model updated and corrected, how to make the online quality analysis and do the product performance prediction, how to do the QPOP, quality-oriented process optimization and control, how to make the multiple product system scheduling and transition, etc. I think the most important thing is to be more and more quality specific. This is our R&D vision. We need to define the quality impacts. We need to do the real-time optimization for the real plant, and we can switch between the multiple products and do the scheduling. So we have three big topics like the modeling and analysis, optimization and the analysis, and finally the optimization and control in changing conditions. So we listed lots of research topics here, and I think each of them can be a PhD topic. Let's have some very brief examples. This is a modeling and quality-oriented optimization for customized polymer production. This group is led by Professor Chen, and it is a cooperative project between Zhejiang University and the Taipei Valley University, very bigger. There are several loops here. You can see this is information flow. The real-time data the hourly analysis of the melting index, the offline analysis of the GPC for MWD analysis. And we need to update the model for the key parameters. We need to do the prediction. We need to download the set points to the control system. So we have several loops here. And the key issue is the model, the static model and the dynamic model. So how to make the very limited information to update the model to have the more insight to the process, and then however we can have embedded molecular weight distribution to be controlled and to be manipulated for the online use. The second one is the transparent factor. The group of Zhejiang University of Technology, Zhejiang University of Amino, and the PSE for speed, they did a lot in the development of analysis and simulation and optimization system for hydrogenation process for amino. Professor Gandhi maybe will talk about that later. This is a systematic analysis, diagnosis, and optimization of the reaction and the catalytic solvent cycle system. The other one is adaptive control and optimization for the compound based on intelligent closed loop optimizing. This project was sorry. Okay, I'm sorry. Yeah, this one was led by Professor Zhu, and it's it is to deal with the consumption and the lots of uncertainties in closed source. So I think this is a very representative applications for the quality topic. Welcome to Zhijiang. We are very close to the West Lake, and this is our 5 of our buildings inside the Zhijiang campus. And I hope you can take time to visit us, and we can talk about the cooperations later. Thank you.